We're going to continue topic 10.5, looking at p-series, and we're going to look at example 2. We just talked about how it converges and diverges, so we're going to figure out what my p-value exactly is in A. So we've got the sum is k equals 1 to infinity of 1 over, and I'm going to change that to a fractional exponent, 3/4, which means that my p is equal to 3/4, which is between 0 and 1. So therefore, because it's between 0 and 1, it diverges. Super easy to tell. Let's look at B. So B is my p-value is equal to 2, which is greater than 1. When it's greater than 1, we know that it converges. So we know that this one therefore converges. And then looking at this one here, it looks a little bit weird. It is not a p-series because my variable is the exponent. So not p-series. However, if I rewrote it a little bit, I could put the k there. It's really the same as the sum as n equals 2 to infinity of 1 over e to the k. It is geometric, okay, with the r equal to 1 over e, and when the r is less than 1, we do know that it converges. So it does converge, it's just not by p-series. Let's take a look at example 3. So we are supposed to determine the convergence and divergence of the following p-series. I do need to see if I can establish a pattern of what the p-value actually is. So I am going to rewrite this a little bit. So I'm going to look at 1 is just 1. It's tough to tell with a 1, but I could rewrite this as 1 over, instead of writing 4, I could write it as 2 squared to the 1/3 power plus 1 over, that looks like 3 squared to the 1/3 power plus 1 over 4 squared to the 1/3 power plus 1 over 5 squared to the 1/3 power plus dot, 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 dot. So it's really looking like my exponent, ooh, that's not what I wanted to do. It's looking like my exponent is actually 2/3, right? Because I've got 2 times 1/3. So my p is going to be 2/3, which we know is less than 1 or between 0 and 1. So therefore it diverges.